So I ran an experiment yesterday with 3 different inoculation percentages for starters. If a starter is fed with 10 times the inoculation percentage, is it going to rise and peak 10 times as fast? This is an experiment to show whether that is actually true or not. And I will show you the chart in a moment, but I will also show you the time lapse that I did right now. Jar number 3 was 120 grams, and it was 80 grams of starter, which was fed 20 grams of new fresh water and 20 more grams of fresh flour. That gives me a 4:1:1 feeding ratio, which means the baker's percentage inoculation would be 400%. 80 of the 120 grams in it is starter, therefore 2/3 of it, or 66.6% of it, is pre-fermented by mass. However, in those 80 grams, there's only 40 grams of flour in 80 grams of starter, because it's 100% hydration, so that 80 grams of starter was made with 40 grams of water and 40 grams of flour. Therefore, we only have 40 grams of flour, and we are feeding it 20 new grams of flour. So in a flour to flour ratio comparison, we have a 40:20, or in other words, a 2:1 ratio of old flour to new flour in this feeding. What that means is that we have 2 grams of yeasted flour, and they have to scramble to feed on 1 gram of fresh flour. That means that resources are limited, so we can expect the starter to run out of rising power shorter and sooner than a larger feeding. Because there's only 40 grams of fermented flour in those 80 grams of starter, the total net fermentation would be 33%, because we have 40 grams of pre-fermented flour and the whole mass is 120 grams. Now that I've explained jar number 3, which is 400% inoculation, I will show you the chart. So far from what we'd expect, the third jar with 400% inoculation went strong up until about 6 hours, and around 9 hours I decided to remove it because it was past its peak. It had started to round out, flatten, and start deflating, so it was losing structure because of that acid buildup. Now, the second jar was still going strong up until about 9 hours, and it didn't really collapse until about 11 hours. After 11 hours, we can say it was getting to the point of overripeness. Now, the first jar that had a very large feeding and a low inoculation percentage of 10.5%, that was still going pretty strong at 12 hours. However, I don't recommend using a starter that you fed and left for 12 hours. Even if the yeast is still going strong, that's plenty of time to build up a lot of acid in that starter, a lot of lactic acid, which can lower the pH of the dough for the bread that you're trying to make, and it can ruin the gluten structure. As we might expect, the high inoculated 400% jar, which is the third jar, it was done the first, is a little bit tangy, has that yeasty smell, but it's a little bit tangy and sour. Now, the second jar with 40% inoculation was a little bit better, and the first jar, number 1, all the way on the left side, had an inoculation percentage of 10.5%, and it had by far the best smell and the least acid buildup. It wasn't sour at all. The key takeaways from this are that your starter strength and its rise time, its peaking times can be affected by moisture content, whether it's highly hydrated, low hydrated, whether it's kept warm or cold, whether you use good flour, and your inoculation percentage and your feeding ratios. Those are the main things that you need to manipulate if you want your starter to have more acid and more flavor of dough structure, or whether you want to promote dough structure more and not have your dough